Hello.
Yes, sir. Ji, sir.
Ma'am, you can continue, ma'am, with the same introduction.
उधर start हो गया.
Okay. Good morning, distinguished speaker, my dear colleagues, and all the participants present. On behalf of AGU family, I, Shatavisha Sinha, Assistant Professor, Department of Engineering and Polytechnic, would take this opportunity to welcome a very dynamic engineer, Mr. Rishi Raj, to enlighten us on diaphragm wall and inclinometer applications. He is presently working in NLW Constructions Private Limited, Chennai. Mr. Raj was involved in the complete execution of a 19.5 meter deep diaphragm wall. He has also conducted testing of vertical rock anchors for judging the stability of diaphragm walls. Now, I hand over the session to Mr. Raj. Sir, please.
Hello everyone. How are you guys? Thank you, Mr. Sinha, for this introduction. Actually, I would like to say sorry just because of some technical issues. I was not able to connect you guys on time. So today my topic is today I would like to speak on topic inclinometer applications and diaphragm wall construction. So guys, first thing is, what is diaphragm wall? So, diaphragm wall is nothing but a normal reinforcement concrete structure casted at site into the panels, and it will be designed just to reach the very great depth so that we can go for the underground constructions. And the thickness of the wall ranges between 500 to 1500, and we can go up to 50-meter depth. Actually, we are calculating the depth based on the confirmatory borehole test, which we are doing for the before starting the D-wall erection. And see the now if you can see the screen, this is how D-wall looks like. And if you are seeing something inclined, that is the inclined rock anchors, just to manage the force after that excavation work. The one side area, the pressure will be more, soil pressure will be more. Just to counter attack that force, we are using these inclined anchors. So why we are going for diaphragm walls, and we are not going for all others, like other different type of construction methods? This is mainly used for going for that underground constructions and making that structure water retainable. And if we are going for minimum space area, and we have to utilize maximum of that, so it will be very space constraint, means we can use maximum of the area where we are going to construct. And we are also doing this type of constructions just because in some of the areas where all the other societies and plants are there, in those areas, if we are going for this type of constructions, so we without going with these type of constructions, means what will happen, the cracks can happen in the nearby buildings. And also, to prevent this, we are going for, first we will go for diaphragm wall, and then we can go for step by step excavation, so that we can prevent that area for any damage or crack. And also we can do all my works. What and all are the advantages? First thing is this: it is a for permanent structure, and it is a top down method. And the construction of this is not as much as difficult, and it is a very fast process to achieve. And the main factor about this is, when we are going for this type of structures, what will happen in future for like we are going for a underground structure, so different type of things will come. So if this type of things are coming, so what will happen that see, in the underground, water will be there, so it will start to come out, so it will delay our process, and it will become costly and to prevent all those measures. So for this, we are going for this type of things, and this it serves as the external wall, and also for the it serves as it works as a uh, external wall for your structure, and also the foundation of the your superstructure, because in if we are going, we can rest our ground floor slab. Suppose we are going for a underground structure. Suppose we are if we are going for a underground structure, so we if we are going for this type of things, our ground floor slab can rest on the that diaphragm wall, which will give us an extra advantage regarding this. And if the main disadvantage, if you like to talk about the disadvantage of diaphragm wall, the thing is it is relatively costly than other methods, but it is fast. And the second thing is, wherever like some of the reason that hilly areas and where uh, hard rock we are getting at minimum depth only, then it will become difficult for us to go to this file, because for these on all these things, for these on all grabbings, we have to go for big machineries and massive machineries, so that we can achieve that. So that will become costly, and it will become a very slow process to conduct. See, if we are going for the construction of diaphragm wall, so we have to follow certain steps. First, we have to construct the guide wall. Then we have to go for the excavation for the diaphragm wall, and after the excavation, so we cannot do the excavation instantly, because we have to do bentonite circulation permanently, so that we can resist the soil collapse inside the trench. And also after that, reinforcement, fabrication, placing and concreting will be taking place. See, and the main thing is, what is guide wall? Guide wall is nothing but two parallel beams constructed along the sides of the wall, as which resist the uh, soil collapse inside the trench from the bottom. And the main purpose of this is, while we are going for a cage installation in the trench, it will act as a platform, and also it will help us to maintain the level of the mm, D wall. Actually, suppose if we have to cast at RL12, then if we are going for RL12 means we can place our case based upon that only, above that, so that we can reach that level. And see, we can also check whether we have reached up to our decided depth or not. We can calculate all these things based on the guide wall top portion. And it is it will gives us a permanent alignment, and it will help us to maintain the verticality, of our uh, trench. And where for bentonite circulation methods and all these collapse and all, it will help us to work fastly. See, when we are going for wall excavation, before going for the diaphragm wall excavation, we have to do CBS test uh, throughout some decided areas where we are going to do the wall, because with the CBS, confirmatory borehole test only, we are going to for calculating the Am I audible? Hello?
Yes, yes.
So sorry. If we are going for D-wall excavation, we have to excavate a bit around 500 to 600 so that our grabber can be placed properly and we can go for the.
Rishi, can you share the screen?
Yeah, my screen has been shared. No, 1 second. Yeah. Uh, Screen shared. No.
Yes.
S- So for if we are going for a D-wall excavation and all, so sorry. So for if we are going for D-wall excavation before, so we have to do some 600 to 500 excavation so that we can place our grabber or whatever equipments we are using, that should be placed properly so that we can maintain that alignment or verticality properly. Or see, the grabber will be coming in use to grab this soil from the for D-wall. And so if suppose if we have reached our depth of the D wall, so how we are going to do the soundness test to check the depth of our D wall. So we what we'll do, we will go for the soundness test. So in this test, we are going to put some heavy weight, and we will be connecting with the chain, and we'll be inserting it inside the D wall, so that when it will touch, it will we will observe or feel some sound, so that with that the chain length we can calculate the depth of the D wall. So in this process, throughout the process, the one thing that should be maintained is bentonite circulation. That should be done regularly without any interruption, so that we can uh, resist maximum number of what to say collapses on all things, so we can as resist all those things. That will be beneficial for us, because if once it is getting collapsed, it will be a rework for us to start at this site. So for ensuring that our the verticality of our D wall, we have to go for codent test. Actually, it is a expensive one. So before going, we should select only 10 or to 20% of our total number of panels where that test has to be conducted. Because in this test, there's some sonic waves will be coming. Not a graph, that will be like a zigzag graph, so that we can came to know that, yeah, this is what where we have excavated more, where there is a soil collapse. That those are all things we can uh, calculate with the help of that coding test. See, these are these if you can see my screen, this is the sequence of the uh, dual panel. See, first we are going for primary panel. So in the primary panels, in dual constructions, after putting the case on all, we have to put the stop ends. That should be waterproofed. In for waterproofing purpose, we should go for hygro bars. That will be easy way to do. See, in the primary walls, if you can see, there will be two stop ends. That curved one will be the stop ends, and the in the middle there is some straight line. No, that there, that is the place where we should we should first we should take be at we should be like more conscious about these things, because if once the stop ends or waterproofing material is not placed properly, it is going to affect our work later when we are going to start for the further works, like while excavations and all, there will be some water leakage and all. So for primary panels, we are going to provide two stop ends, and for secondary, one each secondary panels we are going to construct only one. For closing panels we are not going to construct any of the stop ends. See, bentonite setup. So as I've seen, the bentonite is going to prevent the collapse of the trench. So it becomes a very big issue, means a big, it is going to play a big role in our construction for the D wall. See, the D wall will be like a bentonite mud circulation. The quality of the bentonite should be maintained properly, because for this and all we have to go for certain tests and all that should be conducted frequently at site. If we are not going to do all those things with the bentonite quality and all, if we are not maintaining, that is going to affect our work later on. See, bentonite is like a key see, if you see the, if you can see my screen, the density of the that bentonite should be 1.04 to 1.1 gram per liter, and which we are going to test through mud density balance, and the viscosity will be 30 to 90 seconds. So, in mass con test we are going to put 1 liter of that bentonite solution, and if you'll pass the time taken to pass all that 1 meter, so that is going to calculate, with this only it should not take more than 90 seconds to pass all those 1 liters. If it is getting passed means we have to do some corrections in the mixing. And the pH value is a 9.5 to 12, but we should try to maintain below 11.5 only. And the shear strength will be like 1.4 to 10 Newton per mm square. See, bentonite should be tested as per the standard operating or procedures only. The diaphragm wall excavations, grabbing, whatever we can say, will be done by bentonite and mud circulation to prevent the collapsing and also the caving. And sometimes in the while doing the excavation work, some caves will get generated. So while putting the concrete on, all this has the other wastage of concrete will be more, so we cannot afford that, these are all things. So we should go for this. So these and all things should be uh, some while doing that testing, regular testing programs would be conducted, like slurry fully mixed, and funnel viscosity, filtration, and specific gravity, where everything should be checked properly for the bentonite when we are going to use. And especially density, viscosity, and gravity, specific gravity, everything should be proper so that it will be effective for us. So after the completion of the trench excavation, we should go for reinforcement work. That, as this is a massive reinforcement work will be there in this, so we should do all the fabrication at site only. Or if you are doing for, other than site also, it will be difficult to bring, so that I will recommend to do all these things on site. And the cage lowering should be done properly so that the reinforcement should not get damaged, because once if it is getting damaged, it will become a difficult work to take it out or do again, because if the time of the excavation will increase, the chances of collapse will also increase. So I will show you in the picture, like, see, this is the we are going to use two cranes for the lifting, in the lifting of this, and the specific reinforcement cage should be that cage should be fabricated according to the good for GFC drawing, good for construction drawing only, at site conditions, or based on the availability of equipments. The reinforcement will be placed so that it should not get what to say touched with the trench, because if it is once it is getting touched, it is going to get get the soil collapse. So all these things, like dowels bar, everything for a slab and all, it should be provided at before at the time of fabrication itself, because later on we cannot do at the time of slab casting, and also at the time of slab reinforcement it will become an extra work to do. But because if now itself, if we are providing the dowels bar here, it will be easy to bend and join those dowels to continue the reinforcement. And see, the care should be taken while lowering the cage, and that should be, and proper cover block should be provided, because if you are not providing the cover block properly, what will happen in the future? Placing that d wall, sometimes at some of the some at some of the persons, that reinforcement might get touched with the soil trench, that inside the trench. So while putting the concrete will not reach that touch side. So while doing excavation, that reinforcement will get exposed, and so as it will be in the underground, so the chances of getting corrode, that d wall panel will be get increase. And this is become a difficult one to do. See, in the drawing, as you can see, that two Ks as a has been shown, two cranes has been shown. So two cranes, one will be 550 metric ton or 75 metric ton cranes. Two cranes will be used, and says, see, one will be of 50 to 75 metric ton cane, and the second one should be around 18 to 25, which is based on these site conditions and the weight of the cage, how much weight we are going to take. See, the lowest capacity of the lowest capacity crane should be placed at should be connected with the bottom, and the highest capacity crane should be placed at the top. So
Nivedan sir.
Hello, am I audible?
Yes,
Hello.
Rishi, you are audible.
So sorry for the interruptions, guys, because my internet connections has left, has gone. So if you can see this, sorry for that. So after making the our reinforcement case in a vertical manner, we have to uh, release the ceilings of the lower capacity of the crane. So see, if you can see this in this picture, the insertion of the case inside that trench is in progress. After that, see, if you'll see this, the case has been inserted, and the main thing we should precaution we should take is we should try to lock the case at the top of the wall only, because this is where we are going to uh, this is how we are going to maintain the level. See, in this picture, this is my side picture. This is how we have used this. So after the lowering of this case is getting, hello, hello,
Yes, sir.
am I audible? No.
Yes, yes, sir.
Uh, so after the casing case fabrication and placing and all, everything will get completed, so we should go for concreting. So before going for concreting, we should must do the bentonite circulation for at least for 1 hour. In this process, we have to put we have to put new bentonite, and we have to uh, rel- remove that old one. See, so it will be easier for us. So so uh, bentonite circulation will be very important. This is going to lead us for this is the process we have to execute before the starting of any concrete. And the concrete shall be uh, concreting should be done in a specific manner, and we should maintain the Indian standards of concreting. And the most important thing is, see, our trench will be full of bentonite. So while going for concreting, so the density should must be higher, the concrete density should must be higher. That will, that is going to help us. So if in this process, if you are putting the concrete, if the concrete is of higher density, it will settle down and the bentonite will come out. In this process, that this in these things, the concreting will be done through mm, trimmy pipes, which will have that 250 to 300 dia that should be joined properly and lowered inside the uh, that case and all to do all those things. And they see the trimmy pipes should be lowered up to the depth uh, of the D wall. Like if we are going for 19.5 meter or 20-meter depth of the D wall, we should at least maintain the difference between the depth of the D wall and our trimmy pipe is 300 to 400 And see, while going for the concreting and all, the concreting should must be done without any interruption. So because if any interruption, if we are going to stay hold the process for some minutes or some times, that is going to affect, and that bentonite will get mixed with the concrete, and that will decrease the strength of the concrete. uh, See, while doing the concreting, the hopper will be connected with the trimmy pipes. So that is going to make our process easier. And while doing that concreting, we should lift our trimmy pipe along with that, but we have to take precaution that our trimmy pipe should some portion of our trimmy pipe should must be inside the fresh concrete. and this should be done by skilled supervision on daily basis to ensure correct procedures to carry out all the measures, and we have to record each and everything. And also we should try to put the panel numbers with date, that if anything in future anything happens with these informations, we are going to calculate, get the casting date on all everything. That will be very beneficial for us. See, the concreting should be done till the uh, uh, theoretical cutoff level. So like if before starting the concrete, uh, we should have we did the CBH, and also we have decided the depth. So based on that depth only, we should put the concrete up to that depth, because after D-wall we have to do certain constructions like capping beam, retaining wall and all. Then for this and all things, we have to know the cutoff level of the concreting. And also the after the that concreting completes, top portion of the uh, bentonite should be removed, and also when it gets set, then we have to remove that stoppants without disturbing the waterproofing agent. And this is all about the D-wall. And the main thing is, while doing for D-wall fabrications and all, if we have to install the incline, we have to go for inclinometer. If uh, the applications and all, we have to put one hollow pipe throughout the case on certain decided area where we have, uh, based on that only we will get the deflections. So see, this is what how the inclinometer looks like. See, it is nothing but simple thing, like a simple applications, like it works as a plumb, which we are normally using in our construction field. See, but the best part of this inclinometer is it will give the maximum, sorry, or the minimum deflections, like its least count is 0.1 mm. So we can come to know that how much uh, accurate it is. And this is for like it is very user friendly, we can use it very so if any person like who is having very least knowledge of the geotechnical things and all, or that guy also can calculate the come to know about the wall, uh, how it is getting deflected, how much it is getting deflected. But most of the things it should not go more than 40 mm. With the factor of safety I'm saying, because if it is getting more, so it will become difficult. See, so as I said, how we can, how it works. So in this process I will like to show that, see, once that hollow pipe, steel pipe will be inserted in and after that we have to put one uh, casing, which normal PVC pipe casing, which will have that grooves. So as you can see in this picture, we are having wheels. The wheels will be on the both side, top and bottom of the inclinometer device. In this middle portions, some accelerometer sensor is there. By the help of that only we are going to calculate about whatever based on the data which we are getting, we are going to calculate the deflections. And this side, lower side, we are having a black color cap, that is for battery and all. And it is very user friendly, I said, as I said, because it can be easily operatable from any Android mobile. See, this is how it works. You can see it works on simple like uh, it is working process is very simple. And before going to see how we have to start our work. So after putting that casing, see, we have to put this type of PVC pipe, which is having, as I said, grooves, keyways. So it will help to put that uh, device smoothly inside the up to the depth as we want to go. See, for joining these pipes, we are going to use this Revit pop Revit. To put the pop Revit, we are going to use the Revit gun. After putting all these things, we are going to put two type of step. One is majestic and one is bob tape. Bob tape is normal brown color tape, and majestic tape will be silver type, and it will has like bituminous material, so it will uh, uh, collect the hold the pipe for in a specific way that that we can go for we can easily go for insertion, and it will not it will not lead to any separation of the pipe. So once the pipe will be inserted in that hollow steel pipe, that plastic pipe, once it is getting inserted, so what we have to do is first we should uh, do the grouting of that. The grouting should not be normal uh, cement grouting. It should be like cement plus bentonite, because this heat of hydration of the cement will be more, so it might lead to the change in the positions, and it might get bend the PVC pipe, because it will generate more heat. So we are going to add bentonite. Bentonite should be in 2:1 ratio, so that we can easily minimize that heat of hydration, and it will be good for future aspect. So after doing grouting and all everything, so when we are going for grouting, the main problem which will face the as we'll put the grout in throughout the hollow pipe, not in the PVC pipe, that plastic pipe. So as we can see that outside the throughout the hollow pipe, we are going to put the grout. So in this case, the buoyancy force will come to act, and the pipe will start to come up. So to resist this, we should we can generally fill the water inside the plastic pipe, so that the weight of the pipe will increase, and it will contract with the buoyancy force. Or we have to put the couplers that should be holded by some weight, or like we should put some pin, and those pins are going to hold that PVC pipe. See, and after putting all these things, after the grout is getting uh, set, then we should go for dummy check. Like for before going for any main instrument, we should go for a dummy, so that we will come to know that how it is inside. After if anything is clear, then we should remove the water from the uh, plastic pipe by using that normal air compressors. If we will put, means all the water will come out, and that will be easiest process, because sometimes this water will be there, it might affect the result which we are getting from the inclinometer device. Because as I said, it acts as a plumb. So inside that, if its weight is getting decreased and all, so it will be very difficult. See, if you'll see, means if you'll see the screen, it will be easy for us to operate through the mobile. And in this mobile, there should must be a Bluetooth connection, because the inclinometer device and
the mobile will be getting connected through Bluetooth only, and the data will be transferred through Bluetooth only. See, once that connection will get established through the from between the mobile and the uh, device, this is the type of this. First is that blue color uh, screen that in cardio right digital inclinometer it is showing. This is how it will show. Then the we'll come to know about the second screen, which will show as this is main menu, change password, forgot password, and help, like normal mobile. So if we'll go for, we should go for main menu and get the connection established. See, for once the device is getting on and the phone is getting paired, so it will be very easy to move on to move the process. And see, once the connection will be established, while establishing the that connections, it will show the screen of the your mobile screen will be showing like this. And you can see this connecting to EAN26, some number is there. That EAN some number is the ID of that inclinometer device, or you can say the software ID. See, in this as I said, at certain locations we will have that hollow pipes should be placed, so that we can get the knowledge and all the details about the deflections and all. The thing is, each and every uh, point should have a number, and that should be that should have a different ID, which we can easily make in this hand device, as it is operable from mobile. As I said, it will be like a normal mobile app which we are using. See, this will be the front screen which is going to appear on your mobile once we will start working on this. See, we have to put the inclinometer device like this only. So it will act as two wheels will be there. No, one will be x-axis and another will be y-axis, so that we can get to know the deflections. So main thing is, these and all things should be done before starting the excavation. So for non generally we are going to take three readings, that we will make them as a our base reading, and so that when we cannot excavate at a time, we should excavate step by step, so that uh, we can check the deflections whatever it is coming. See, when we'll start to take the reading, see, at 90-meter depth if we are going means, this is the data coming A or B value. And inside, if you can see that some voltmeter will be there, which will getting fluctuated as inside surrounding the noise and all, because noise and all are going to play a vital role in this, because sometimes it might affect our readings. So we should try to maintain this as minimum as we can. And we are going to take the reading at each 0.5 meter. See, this is the bracket. As I said, we have to hold the device at the top. This is the 0th meter reading, so that once if we are taking the reading, as I said, in this picture, if you see the wheels, if you see, this is x and this is y axis. If you are once if you are taking with the x axis, next time we have to go for y axis also. The same thing, both the things should be taken. See, if you see, that should be facing, that should be perpendicular to the see. This is what we are going to get this is the normal format. This is normal format. If you'll see means, this these readings, how we will get the readings, these are the readings which we are getting based on one normal formula, L sin theta. See, these are all phase A plus A minus 2 readings will be coming. After A plus B plus will be coming first reading. After that, if we are rotating the device at 180 degree, the A minus and B minus reading will be coming. So mainly we'll consider only A plus reading, because we are going to do the excavation only in only one side. If we are going for the both side, we have to consider the both. So based on these readings, see, we have calculated one base reading, that is the average of these readings. As I said, how it works, L sine theta, as I said, L will be the length of the inclinometer device. See, I will show you. See, this L will be the length, and the theta. See, once the pipe is straight, it is going to make some angle while placing this, inserting that sensor. That theta and that will be our the deflections which we are getting the data here. As I said to you, is see, this is the data which we are getting. See, after getting this data, we are going to calculate the mean, because we are getting four values. Four values if we are getting this, we have to calculate the mean, and then we have to, each mean we have to calculate the cumulatives. A- as I said to you that, see, these are also are the what to say, uh, axis. This is how, if this is the panel A, x-axis, y-axis, like that, as I said, this is really the thing. This is how it works. And see, in this every data, everything will be shown in this and screen, and whatever we can see. As I said, I site code as a, if you have made an RMZ, if you are working, if you had made XYZ, whatever it is, you can make. And for each bore there will be some code which you have to select, and each bore will have some certain depth. So that should be collected, and at what depth we are going to calculate the readings. See, after the readings, the daily readings, base readings. So as I said you, the first readings will be base reading, and based on the base readings only, see, this is the base reading. See, next day, if after excavation, see, if you'll see some deflection will be there, some changes will be, we can see daily some changes, because its least count is very minimum, so we can see maximum number of changes. Now means after some time also, if you are taking the readings, there will be some changes, because it works, the sensor works as normally as a plumb bob which we are using generally. See, based on this directions, see, this base reading will be 0. See, after that, the second 20, if you'll see 20 August, as date has been mentioned, for based on these readings, the deflection is 0.7, 0.8, 0.77, 0.75, like that reading. Means this is 0.77 mm. This is not also 1 mm. This is minimum more than, sorry, less than 1 mm. See, like that, daily deflections and daily excavations happens, and this is how the deflection will increase. So if once if you get the data, this graph will be day by day. You can plot these graphs. These are all the graphs which we are going to help how wall has got deflected, and which depth, how much it has been got deflected. See, at 19 meter it is nothing. So as we are getting, see, this is like a curve, right? This is how, this is the real position of the uh, dual, uh, right now at the time of, say, at the 4th February, as I had mentioned, the 4th February, that yellow color line, blue color line, whatever it is. See, this is the position of this wall. See, similarly, we are going to check with face B. See, the face B will be showing opposite direction movement, which is not at all that much of possible. See, one thing which has been observed, that one, in rainy season and all, the deflections will be shown more, because the soil pressure will be more from one side. So it is going to show the more deflections. So that we should try to resist the deflection up to 40 mm. Because if it is getting increased, means we have to check each and every day. As I said you in the first slide, as I shown you, that some anchorings will be there. So the the cutting excavation of the soil should be done in a certain level. So, at each level you have to go for anchoring. At each level, if we are going for anchoring, means it will be easier for us to. So I will show you guys. See, at each level there is some anchoring that should be to counteract the soil pressure from the other side. See, if you'll see this, if at one portion that 5 meters depth there is more deflection at that time at all those areas. So in those areas we have to check the stressing, because sometimes due to more pressure the stressing will get somewhat loosened, or uh, it will be not stressed properly. So we have to check to send that back, to make that wall in a straighter manner. We cannot make it fully, but just to maintain that properly, we have to check with the we have to do stressing again, and we have to increase the load. Then only we can counterattack that load. Thank you guys. This is all about inclinometer applications and D-wall constructions. Do you guys have any questions? Hello? Hello?
Hello.
This is all about, sir, about that dual constructions and inclinometer applications. And do you guys have any questions regarding this?
Anyone have any question?
So I can take your silence
Sir, one
as you
question from
guys.
Subham sir
Huh? Yes, sir.
in chat box.
Chat box. Okay, sir. Sorry. Chat. Sir, what are the essential needs to taken during diaphragm wall cohesive? Yeah. Okay, I will answer him. Or any questions?
No sir, no any question.
Okay, sir. I will answer him here only.
So there is one more question.
Yeah.
It says, how is bentonite slurry poured prior to concreting? This is from Mr. Aditya Raj.
The concrete slurry will be poured by using normal. See, for this we have to make some setups like 2-3 tanks. Then with the help of those 2-3 tanks only, we are going to. I will say, wait. My screen is shared, no? Hello.
Yes sir.
Yes, you are audible.
Okay, okay. So I would like to show you like some bentonite setups would be there. So that bentonite setup, like 2-3 tanks we have to place, and we have to put it with normal motor and pipe through into that trench, so that it will get poured continuously without any interruptions. That is a normal setup which we are using at site. If you'll go, means you can check. It is a very easy process.
So thank you so much, sir. I hope
Thank you.
he is satisfied with the answer. with the answer. There is one more question from Mr. Raj. He's asked, what are the phase A and
Phase A
in
and phase
inclinometer?
B. Phase A and phase B readings. Yeah, actually in the inclinometer, there will be two axes. No, as I have shown. See, I would like to. Sorry, Subham sir. I will message you. I will send you. I will clear all your relative doubts. As wait. Yeah. See, if you can see my screen. See, there is some panel number has been shown. No. See, as you can see my screen, there is some panel number will be shown. In that main portion, as I said, that face reading will be that. See, as we have in this picture, if you see, means we are inserting the probe front, that top will be a face A plus and B plus, and the lateral side will be A minus and B minus. In these sides there will not be any movement. That's why we are not going to consider about this one, but uh, uh, we are going to consider only A plus and B plus only, because it is going to move perpendicular to the D wall.
Thank
Is
you,
it
sir.
clear?
Yes, sir. Thank you so much. There's a
Thank you.
question from SK. Um,
Uh-huh.
it says, what is the temperature of pouring in inclinometer through slurry?
That
Temperature of
should be
pouring.
around minimum temperature.
Yes, sir.
Temperature should be like I would like to tell you why. Right. I have to check. It should be temperature should be 5 degrees Celsius to 32 degrees Celsius, and the slump which we are going to use is 150 to 200.
Thank
Hello.
you, sir. Yes, sir. Thank you.
Okay.
There's another question from Mr. Aditya Raj. He asked, how do we fill the trench fully with bentonite?
With normally with that, as I said to you, the uh, it will be filled with normally with that what to say, normally bentonite setup is there. No, with the bentonite setup normal, with pipes and all, we can pipes and motor, we can fill that trench.
Mm.
It's a easy process. Very
Thank you.
means
One more question from Mr. Harsh. He asks, is the device government approved?
yeah.
Thank you.
Mainly it is a it is having different sets of companies which they are using, manufacturing these things. Mainly it will be manufactured in Lucknow. Mainly it will be manufactured. For any changes and all, we have to send our for any like checking and all. And if anything goes wrong with the device, we have to send those our equipments there only, or their engineers will be coming and they will be checking.
Thank you so much, sir. There's a
Thank you.
question that's asked, basic installation errors and the maintenance problems in inclinometers. Or is
See,
there any
maintenance is
relevant codes to it?
a relevant
Are there any
report.
relevant codes, sir? I use codes.
No, there is no code for this. I check, actually I have not come across with any type of this type of codes and all, so I can't say. So but it's maintenance is very easy, just to need, as I said, if we are putting the water and all inside the PVC pipe, so what will happen, so if we are taking our readings daily, then it is going to affect our machines. Like if you see the machine, see the device, some ferrule will be there. in that ferrule, no, some marks will be there, means depth will be as a, we cannot say that this is what the depth which we are taking the readings. So on the ferrule there will some mark depth, so that depth will we have to maintain it properly.
Okay. Thank you, sir.
Okay, is there any
And
question
one
more?
question, that is, what are the essential needs? Yes, so one more question. It asks, what are the essential needs that
Sorry,
are to be used, sorry, I'm sorry.
your voice is
What are
not
the
clear.
essential needs to be used?
Huh?
Am I audible now?
Yeah. What are all are the essential needs?
Hello.
Hello.
Oh. What are the essential needs to be used? The question says, what are the essential needs to be used by placing diaphragm, and will the use of equipment affect the productivity?
Yeah, the the type of the equipments which we are using will affect our productivity, because we have to be 100% sure, and we should select the equipments based on our requirements only. We should not go for for that all the setups or all the process, no, it will make a big mesh to work on. So for these and all things, we should try to minimize as much as we can, and we should use only essential things what we are going to use.
Okay. Thank you so
Hello.
much, sir. I hope all our participants would be satisfied with these answers. And now I would hand over the
Okay.
session to Professor Kumar Shubham to conclude the
Shubham,
session.
yeah.
Thank you, ma'am. It was really a great session, sir. Students came to know about the field works which they really lack in their theoretical subjects. So I would like to thank you on behalf of ARKA JAIN University
Mm,
for accepting our
thank you.
request for the session.
Thank you, sir. Thank you. Thanks a lot. Because in this lockdown, it gives me an opportunity. This is my first webinar which I have ever taken. So I would like to say sorry if I have missed anything, or some repeated things I have said no. For that only, I would like to say sorry for this, because this is my first webinar which I have taken till now.
Okay, sir. Thank you again.
Thank you.
Thank you, sir.
Thank you. Welcome, ma'am. Thank you, guys. So now I'm leaving.
Nivedan sir. Hello. Sir, Nivedan sir.
Yes, ma'am.
Kar de end.
Yes, ma'am. You can.